Good morning everyone and welcome to today's webinar. My name is Pamela Howitt and I'm Senior Technical Advisor here at the A. Proctor Group. Today we have a special guest presentation from Peter McConnachie and Nicola Jackson of Robertson Construction. Peter and Nicola will discuss their approach to Passivhaus construction and net zero and how they applied this approach to educational projects, most recently at the new Riverside School in Perth, which used our Wraptite membrane. If you've missed any of our webinar series, which has been running now since 2020, you can view them all on demand right here in our YouTube channel or on our Learning Hub at www.proctorgroup.com. As always, we'll be following up with a Q&A session, so please send us any questions you have to webinar@proctorgroup.com, by Twitter DM or in the YouTube chat box. And I'll now pass over to Peter and Nicola to begin today's presentation.
Hi, my name is Nicola Jackson and I am a Net Zero Projects Leader in the Robertson Group. Today I've got an overview for you of the Robertson business, and I also want to introduce our Offsite Manufacturing company, Robertson Timber Engineering. And I'm going to be sharing information with you on how the use of offsite manufacturing can assure quality in construction to enable Passivhaus performance standards to be met. So the Robertson business, it's one of the largest family-owned construction, infrastructure and support service businesses in the UK. Our purpose as a business is to assure a sustainable future, and we are achieving this through projects we're delivering, the supply chains we work with and the communities we support. Our business has over 5 decades of experience, and we've now grown to a team of over 3,000 employees. We've got 10 offices across the UK, and we have a positive outlook going forward with a £2 billion forward order book. Within the company, we operate a separate residential business, which has 3 divisions, delivering affordable homes to a company delivering homes for first-time buyers and people looking to downsize, and also high-end homes. As a business, we can have a significant impact in reducing carbon emissions as we work across the entire built environment life cycle, from investing to developing and constructing all types of projects. And we also have a facilities management company who look after the buildings when they're in use. So with over 22 different companies working across the UK, we can work locally within different communities. Our offices are as far north as Elgin, which is where I'm based, and we go as far south as Sheffield. Our Offsite Manufacturing company is based up in Elgin in Murray. And as a business, we have moved from being carbon neutral to being climate positive as of 2018. And this has been achieved by reducing our carbon intensity by almost 68% since 2014-15. And this has been done through our carbon management plan, through smart waste reporting, through climate change awareness training, and also through an electric vehicle fleet rollout. And now I want to share some more information with you on our Robertson Timber Engineering business and the use of offsite manufacturing. So the Offsite Timber Engineering business has been in operation for over 35 years. And within this company, we design, manufacture, deliver and erect precision-made timber frame panels, which will go into all building types from hotels, hospitals, schools and housing. Our offsite construction processes at Robertson Timber Engineering can help to reduce embodied carbon. And this is through efficiencies in our offsite manufacturing process, where we've got standardized systems in place that allow us to make continuous improvements. Our systems allow us to install components with a high degree of accuracy and to the correct tolerance. We're able to reduce waste in our processes through using automated equipment, and working in the factory allows us to more easily use leftover or waste elements on the next project. We can reduce transport emissions by working in the factory, by working with a local fixed workforce within the community, and also having established local supply chains set up. As well as reducing embodied carbon, the use of offsite construction will also help to assure operational carbon targets are met. And this is done by ensuring that the insulation is installed correctly at the correct density and volume, and it's being put in a dry environment. We're installing the membranes and tapes around openings in the factory to ensure the airtightness requirements are met, particularly for Passivhaus. And here you can see operatives in our factory, and they're installing Wraptite insulation, Proctor's Wraptite insulation onto external wall panels. As our operatives are installing these components, we're using a digital platform to make quality checks within the factory, and this ensures that all elements have been installed correctly, and there's an audit trail of information to verify that elements have been installed correctly. Going forwards, we're looking at how we can build more offsite to increase pre-manufactured value and reduce both embodied and operational carbon in the buildings that we deliver. We're looking to use higher levels of automation to deliver on this. And now I'd like to hand you over to my colleague Peter, and he's going to talk to you about the Passivhaus projects that Robertson have delivered.
Through the Climate Change Act 2008, the UK government is committed to becoming a net zero greenhouse gas economy by 2050. This commitment was signed into law in June 2019, with the Scottish Government passing the Climate Change Emissions Reduction Targets Scotland Act, which aims to reduce the greenhouse gases by 75% by 2030 and achieve net zero by 2045. Net zero means that the balance between greenhouse gas emissions produced and greenhouse gas emissions removed from the atmosphere is equal, resulting in no net increase in emissions. In practical terms, the drive to net zero involves transitioning away from activities that generate significant amount of greenhouse gases, such as burning fossil fuels for energy and transportation. Instead, the focus is on adopting cleaner and more sustainable alternatives, including renewable energy sources, energy efficiency measures, and low-carbon technologies. Using various methods of collecting evidence, including collecting data from ice cores from polar ice caps, sedimentary cores from ocean floors and seabeds, researchers can cross-reference the information and determine the levels of greenhouse gases present in the atmosphere over a prolonged period. The burning of fossil fuels since the start of the Industrial Revolution has seen the quickest increase of its greenhouse gases in our atmosphere, causing changes to weather patterns globally, increasing the risk to our health and well-being. The last few years have shown that the reliance on fossil fuels also has an economic effect, not only on households, but all energy users directly, with the upward spiralling energy cost straining budgets nationwide. The shift to net zero is not only crucial for mitigating climate change, but also to reduce our dependence on imported fuels, increase innovation and economic growth by creating thousands of green jobs. Buildings are accountable for approximately 35% of total global energy consumption. We need to reduce this demand on our infrastructure and our environment as quickly as possible. Passivhaus can help deliver these goals. The Passivhaus standard is a world-leading standard in energy-efficient design. It delivers an incredibly high level of occupancy comfort, using very little energy for heating and cooling. This is achieved through a whole-building approach with clearly defined targets, adopting a fabric-first approach, and focusing on the highest standard of quality assurance. When designing, the 5 principles of Passivhaus are important to remember. Airtightness is key. Passivhaus standard achieves a minimum of 0.6 air changes per hour. This is not to be confused with the air permeability, which is the volume of air escaping per metre squared of external surface area, which is the standard measurement for buildings in the UK. Although the results this low may appear similar, the current building regulations for new buildings is currently a maximum of 10 metres cubed per metre squared per hour, typically achieving 5 metres cubed per metre squared per hour. This is significantly higher than Passivhaus achieves through the implementation of membranes, grommets, tapes and detailing. Continuous high-performing insulation with no gaps in it. The construction industry already uses high-performing materials regularly. We need to increase awareness of installation practices and the effects that mistakes, poor detailing and poor workmanship can have. A 2 mm gap in the insulation on the warm side can result in a 12% increase in heat loss from that area. A 15 mm gap can be a 520% increase in heat loss. Reducing or eliminating thermal bridges throughout the fabric of the building is critical. Think of heat in a similar fashion to water. If it can find a path to escape, it will. Various materials conduct heat more effectively than others. High-performing windows and doors, tested to rigorous standards with thermally broken frames, ensure that the heat generated in the building remains in the building. Triple glazed units are specified as these perform thermally and have the additional benefit of reducing external noise. Mechanical ventilation with heat recovery controls the ventilation in the building. Systems commissioned and balanced correctly recuperate a high percentage of the generated heat, thus reducing the energy demand for heat. Passivhaus buildings deliver other benefits as low energy use means reduced costs. A Passivhaus school can use up to 80% less than one built to traditional standards. The highly focused attention to detail from design stage to the installation of materials and products reduces the risk of defects and can reduce the maintenance of the building fabric, typically caused by poor installation. Construction of the building to the highly detailed design ensures the building operates as modelled from air quality to energy usage over the lifespan of the building. CO2 levels under 1,000 parts per million are considered healthy, with outdoor levels often as low as 400 parts per million. Indoor CO2 levels average between 420 to 1,000 parts per million. Although indoor CO2 levels are typically below 1,000, having over 20 students and teachers in an enclosed classroom would naturally raise the CO2 levels, and it's not uncommon that the levels can go beyond 3,000 parts per million. If levels rise above 1,000, people could experience mild symptoms such as drowsiness, restlessness, increased heart rate, and difficulty breathing, such as yawning, deep breaths, etc. If levels of CO2 rise above 2,000 parts per million, it can cause a marked reduction in the learning and concentration, as much as a 50% reduction in cognitive behaviour, and may cause discomfort with symptoms such as nausea and feeling stifled in addition to the one previously mentioned. As we have seen with the recent global pandemic, respiratory illnesses can affect anyone at any time, with ventilation playing an important role in the reduction and transmission of viral and bacterial infections. MVHR controlling the air into and extracted from the building monitors and ensures that the CO2 levels are lower. The heat is recovered, thus reducing costs. Allergens, pollen and dust is filtered, leaving a higher standard of indoor air quality. Material selection and specification plays a significant part of ensuring the building operates as designed. Material compatibility with other elements is crucial. Sequencing of installation, exposure to external factors such as extreme weather, UV radiation should also be considered. The location of the air tightness barrier also plays a part in the installation and selection of the material. Should it be internal or external? What are additional trade interfaces? Adjacent material installation methods. What is the substrate the membrane or the product has been installed to? On site, the air tightness champion is a designated member of staff that works with the building fabric contractors to ensure the material is installed and protected following the manufacturer's recommendations and guidance. Recording of detailing, penetrations for external services, either electrical or mechanical, need to be documented. Continuous monitoring of installation and recording for records is important. Whether images, videos or proprietary systems are used, this process is useful for helping identify any issues that arise and your air test may raise. Working with manufacturers' technical departments is a key to ensuring a quality installation. They have researched and developed the products, they know a lot more, they've seen a lot more and have a lot more experience that we in the industry have and we need to achieve. Sectional airtight testing of larger buildings is possible. Ideally, the full external envelope would be tested prior to external installation or facade being built. However, in educational buildings, this is not practical due to time constraints. Smaller testing of individual components is advised using readily available tools. You can pressurise a fully fitted window or door by creating an airtight tent of polythene and pressurise it using a leaf blower and check internally with a smoke pencil for leaks. Remedial works for damaged systems should also be considered. How readily is a product available? How easy is it to repair? How easy is it to complete additional work that is required? The Passivhaus process delivers a proven method of achieving low energy buildings. This allows local authorities to manage their energy usage costs effectively, which are typically 80% lower than the standard design, as the usage for heating, lighting and electrical equipment is calculated in advance of the construction, with some variation allowed for. The usable space is significantly more comfortable than buildings completed to existing standards, as the high specification ventilation results in improved indoor air quality, the insulation stabilises surface and air temperatures internally, the shading installed prevents excessive solar gain and overheating in the summertime. These all contribute to a better learning facility. The addition of natural materials can encourage a more inviting atmosphere. Improved acoustics due to the construction of the external envelope and additional attention to detail on the internal walls results in a space with less noise distractions. Passivhaus has an independent third-party certification process, thus ensuring that the construction is of a verified quality. The attention to detail during construction, with particular scrutiny over the insulation and airtight barriers, deliver a building with lower maintenance requirements, which in turn results in less disruptions for pupils and staff.
Good morning, everyone, and welcome to our May webinar, not our Way webinar. If you've missed any series, as I said at the start of the presentation, we've been running these since 2020, and you can view them all on demand right here in our YouTube channel or through our Learning Hub at www.proctorgroup.com. You can also register there for all our online members area benefits. You can access product information, personalised CPD certification for our webinars and presentations there. And there's also access there to register for our free online U-value and condensation risk calculation. You too can be one of these techies. As always, after the presentation, please get in touch if you want to request any product samples, arrange a follow-up meeting to discuss any of your specifications or projects that you've got on the go, or to contact us about booking one of our REBA or normal CPDs that we've got. We've got a huge range of topics that we can cover. These can be done both face-to-face and online. So if you've got a large working demographic, no problem at all doing that online. As mentioned on the start of the webinar, please do send any questions you have to us. We've got a few coming in here. I can see through the YouTube channel. We've got some by email and some by Twitter. So please send them into webinar@proctorgroup.com. DM us on Twitter, which is @proctorgroup, or type them into the YouTube chat, the easiest way. Right, without any further ado, let's get on with the question and answer. Let me introduce our guests today. On the panel, we have Nicola Jackson, who is the Net Zero Project Lead with Robertson's. Good morning, Nicola. We also have Peter McConnachie, also of Robertson Construction, and his role in the company is Passivhaus Manager. And Linda and I met Peter on an extremely wet, as the Scots say, dreich, pouring wet day to look at the install of Wraptite at Riverside School. Good morning, Peter.
Morning.
Now, another couple of well-known faces from the webinar series. We've got our Regional Technical Sales Manager, Linda Kay, and she covers Scotland and North England. We're quite lucky to have her at home today. Good morning, Linda.
Good morning, everyone. Morning.
And finally, we've got Sue Memure, one of our technical advisors who has to put up with me on a daily basis. Morning, Sue.
Good morning.
Okay, so without any further ado, let's get on with the questions. So the first one I got here came in through the YouTube feed. Linda, I'm going to put it to you if that's okay. I'm looking for something to help with air leakage at openings and also to help with joints when installing insulation. Can you please advise? And this was from James Wilson.
Morning, James. Thank you for the question. So a useful way of sort of stopping unnecessary air leakage around openings and overlaps is to use our Wraptite tape. So Wraptite tape is flexible, it's ease of application and detailing, if you like. It's also got a resilient composition, so it resists punctures and tears during construction. And it's also suitable for airtight sealing of membrane overlaps when you're actually joining the insulation joints. So it has a high vapor permeability, so it allows that damp sheathing, if you like, to quickly dry and moisture vapor to actually escape as well. So it's very good for both of these things. Hope that's
Brilliant. Thank
James.
You, no problem. That's great. Thank you, Linda. Peter, if you don't mind, can I come to you for the next question? This is from Polly Williams, and she asks, does achieving Passivhaus occur additional costs?
There is additional costs in the design and development stage. It's a front-loaded design process. There is the independent certification, and there is potentially some additional materials that wouldn't normally be specified for a traditional build. However, when you offset that against the energy savings throughout the life of the building, you're actually saving money in the long term. So there can be an additional outlay. Construction costs can be designed to be the same as a traditional building, but there's a heavier design element.
That's brilliant. Thank you, Peter. Nicola, we've got one here from Marina Phillips, if I can come to you for this one. How can Passivhaus deliver whole life value? It falls on quite nicely from what Peter was saying, I think.
Yeah, sure. So it can deliver whole life value as it helps to lower running costs over the lifetime of the building. And there'll also be lower maintenance costs from having a simplified system. And it would mean that you wouldn't need to retrofit that building to meet net zero targets going forward.
That's great. Thank you very much. Sorry, I was just keeping track of everything. Missing it there. Thank you very much for that, Nicola. So one here from you on the YouTube feed from Greg Robertson. What sort of air tightness levels are achievable with Wraptite? We obviously heard in the presentation there was some mention of targets and values, but how can Wraptite help us?
Yeah, certainly we've seen projects with extremely low levels of air tightness being achieved when using the Wraptite membrane. If anybody watched our previous St Sidwell's webinar, then you'll have known that it exceeded their target of 0.4 air changes per hour. So Wraptite, so as well as being, it's obviously an airtight membrane, so it does allow those very low air leakage results, but a lot of it is also dependent on several other factors. You can't just rely on using the membrane itself. So you do have to take things like workmanship into consideration, how you handle any repairs on sites, and also those sort of awkward areas like junctions and detailings around windows, penetrations, etc. So you can obviously you could potentially have the best installation of Wraptite ever, but if you have a wee leaky window installed, for example, then that can totally just knock your building's air tightness result, off kilter, as it were.
Yeah, I think that's right. So, just to bring it back to what Peter was saying in the presentation, that sort of 520% heat loss through was a 13 mil gap or something like that.
Yeah.
That's quite an amazing statistic, and it's frightening when you think about how gappy we can or have been guilty of building buildings. So that's really good. Peter, I'm going to throw this one at you. This is kind of one from me, but obviously Robertson's had quite a lot of from what we saw on site, it was an excellent install of Wraptite, but you had quite a lot of practical hints and tips that you did, didn't you, in terms of how you sort of made sure that the install was going well and identified any damaged areas?
We find that having a benchmark installation for the guys to see when they come onto site, because quite often squads of tradesmen will change, and showing them the quality that's expected, doing daily checks of the areas that we've done, finding out what materials are compatible with it, because there might be something that, although it's been specified, it's never been actually used before. On paper it might work, in reality it might not, and I think that's probably crucial, and a diligent process of quality checks.
Absolutely. I think we identified that in one where you sort of panicked phone call to me in the morning because it was a compatibility issue, which actually brings me on to one that I'm going to came in by email, Sue, and I'm going to put it to you. It's more of a techie based one that came in from Olga Jepson on email. She said, are there any compatibility issues between Wraptite and waterproofing lines, i.e. at the roof or ground floor junctions?
Okay, so yes, it's obviously very important to check that when you are trying to put a waterproofing line over the Wraptite, you have to ensure that the two products are compatible. So typically things to watch out for include mainly chemicals in the waterproofing or the primers that could affect the membrane. So these generally tend to be solvents. If the waterproofing, for example, is a heat applied product, then obviously care should be taken to make sure that that heat doesn't damage the membrane while you're actually installing it. If you are looking for, it's like primers, for example, then acrylic primers or water-based primers are usually compatible with the membrane, and they can be used if needed. But Typically with roof shield, roof shield's obviously quite a smooth surface, unlike concrete, for example. So it's more than likely possible that you can actually install your waterproofing without the use of any primers, like in any case. But regardless of what you do, just obviously make sure that when you're layering waterproofing and membrane, for example, that you're making sure your overlaps are to shed water outwards rather than inwards. There is a word for that and it's gone out my mind.
Shingled effect.
Shingled.
Friday morning, our brains are starting to shut down for the weekend. That's great, thank you, Sue. Nicola, I think there's one come through from YouTube here, which, if it's okay, can I pass on to you, from Siddiqui Mohammed. Could you please inform us how thermal bridge calculations were performed, what software was used, and if it was possible to reach a thermal bridge-free design?
Yeah, so you can use Therm, like there's various tools that are out there, but Therm is a free one that you could use. And you obviously want to mitigate thermal bridging as far as possible. And yeah, it is possible to achieve that through good detailing and spending the time at the design stage to work it out, but also looking at the buildability of that, whether it's practical to achieve it.
I think that's a big thing, isn't it? Quite often you can design it, but you can't actually put it into 3 dimensions.
Yeah, Peter will be able to add to that.
Perfect, thank you. Right. Peter, this is probably one for you actually, from Rod Taylor on YouTube. How much maintenance is needed for the ventilation system in a Passivhaus building, particularly in a school with a large number of pupils?
If the ventilation is installed and balanced properly, it should be minimal maintenance. It should be filter changes. That's critical because quite often people will put ventilation systems in, not check the filters, and then they're obviously struggling to operate at their approved capacity. It should be minimal. I mean, once the system's designed and balanced properly, it should just be a case of changing the filters. It'll all be set up with CO2 set points and with the heat recovery set points, so it shouldn't need a great deal of maintenance. Seasonal commissioning might come into play, so for the first 12 months, there might be a bit of tweaking of the software and a tweaking of the system, but it should be pretty, once it's set up and go.
That's brilliant. If I can stay with you, Peter, there's another one on YouTube from John Malik, or apologies if I've pronounced anybody's names wrong today. Can you elaborate on the air tightness champion and how they work with the team?
The air tightness champion, it's part of the site team. Independent from a site manager, he goes around monitoring the external penetrations for mechanical and electrical services, checks all the detail, and particularly at normal weak points, so slab edge to wall, roof to wall interfaces. If it's a steel building, there'll be structural steel work detailing. Just really, it's just to be. I would put it like a clerk of works position, but with a high focus on the airtight envelope of the building, just to make sure, because obviously that's where you will lose your most heat. That's where your building will fail.
Absolutely. Thank you, Peter, for clarifying that. Linda, just so you don't feel left out, can we come to you for this one, please? This is an email from Trevor Wade, and he asks, I'm a contractor and have never used your products before, and we've been asked to install it on a new project. What assistance is available?
Well, first of all, you can go onto our website, which is very informative. It has install details, it has performance specification. So there's a lot of different things there. One of the things that we do, and you'll know yourself, Pam, is we do go onto site. But prior to that, to sort of looking at that, we can actually talk with the contractor or whoever's installing it and actually give a toolbox talk. So they last about 30 minutes and they're quite informative. It lets everybody have a Q&A, if you like, if they're not sure of how to detail it, and we can actually go onto site and help them put it on, if you like, actually detail it onto site. And we do go back and we can actually look at the installed product for you and make a report. As you said, we did that with Peter. We went on, checked some, if he had any issues and made recommendations. So we do that as well. We put that in a report. And if that's not something that you want to do, we're quite happy just to come onto site, check it over with you, discuss it, and then come on to site again. It's not an issue at all. Any help we can give, really.
Yeah, absolutely. And, you know, the technical team are here at the end of a phone call. So yeah, absolutely. Sue, if I could come to you, this is one from George Simpson on the YouTube chat. Do you have a comparison of a wall section with and without the Wraptite installed and the air tightness levels achieved?
Do you mean like actual test reports?
I'm not sure, George, perhaps if you're still here, if you could pop an update. I'm kind of reading that as, do we have almost like a U-value calculation where we can look at the difference of air tightness, but that's quite a difficult one because it's so many other factors influence, doesn't it?
Yeah, absolutely. But yes, if George can obviously clarify, like what it is that he's looking for, then we can look into that further.
There are some of our other webinars, George, about Wraptite, where some of the low energy design ones, where we actually have like sort of indicative stat calculations. So by increasing the air tightness and looking at that against insulation thickness, how you can actually bring your overall design criteria down and improve the overall carbon.
The relationship in SAP as well, like where the better your air tightness, then potentially you can make savings elsewhere, like on, like as you're saying, like thickness of insulation, for example.
Yeah.
So there is sort of like a bit of a, like a correlation between like low levels of air tightness and your emission rate,
Yeah, absolutely. So we don't have anything specific, but we've got some ideas of what you can sort of change about and switch about in some of our other webinars. Thank you, Sue. Okay. Nicola or Peter may want to jump in here. An email from Tony Gordon. Do the team at Robertson's have a preferred insulation type when building to passive standards? If they do, why do they choose that insulation type?
It's flexible in terms of the insulation type, and it depends on the performance value that they're looking to achieve. Like it could be less than the minimum value that they're looking to achieve. And it also depends on the embodied carbon figures as well, as to whether you go for like a mineral wool or a PIR based insulation, or whether you look to like bio-based materials such as wood fiber. So it's flexible, I would say. Yeah.
Yeah. Okay, that's great. Thank you. This is probably a good one for you, Peter, from Mark Drury on YouTube. Is Passivhaus more suited to off-site construction? We'd probably say no.
Yes, I'd say
both.
No, Passivhaus is a process. I think a lot of people misunderstand it because they've seen some things about Passivhaus on TV, but it's a process. It starts with the design. So yeah, that could be off-site. The implementation, there is definitely some advantages to doing it off-site, but traditional methods of construction that we're used to in the UK, you can't do that all off-site. You have to deliver it on-site. So there isn't a specific benefit to doing it purely from off-site construction. No.
It's a difficult one, isn't it? Because
it is. It's an open-ended question because there is benefits. It's a difficult one to answer, I'm afraid. Yeah,
it's balancing it. If I can stay with you, Peter, or maybe Nicola will have this information. Mark Morley on YouTube is asking, what air tightness result did you achieve in this project?
We achieved 0.34 air changes per hour.
0.34 air. That's good. It's really good. Thank you. And Mark's also asked, and I think, Sue, if you don't mind me asking you this one, because we get this constantly or often in technical. If you use Wraptite, do you still need an internal VCL?
Oh, yes.
I'll use Ian's phrase.
It depends. It depends. So basically, the vapor control layer performs two functions. Obviously, it reduces the amount of vapor that can pass into the construction in the first place. But due to the nature of what, VCLs are generally either sort of like foils or polyethylene based, they are, they're by their nature, they're airtight anyway. So they do also provide your air tightness line. Now, obviously, using the Wraptite, we would generally use the Wraptite on the external face of the building, just because there's less penetrations. It gets a lot easier to install that way. You're not necessarily puncturing it in the same way as you would an internal membrane. So from an air tightness point of view, obviously using the Wraptite is taking away that function of the vapor control layer. But depending on what your construction is, what your building use is, for example, as well, you may or may not still require a membrane internally to provide that vapor control aspect of it.
Brilliant. Thank you, Sue. Peter, if I can come to you, we've had a Twitter DM from Mohinder, and he's asking, what about a building's need to breathe?
The building still breathes, but it's controlled mechanically with your MVHR units. So I don't want to say it's like putting your building on an artificial respirator, but that's exactly what it is. It still breathes, but you are controlling all the airflow in the building through use of air transfer grills, through extract, supply ductwork, and it just gives you a more comfortable internal environment.
That's great, thank you. Nicola, if I can come to you for this one, what do we need to enable the delivery of Passivhaus standard at scale?
Yeah, so to do that, we need policies to be in place from government, and that's coming through in housing, say, like through developing a Scottish equivalent of Passivhaus standards, and it's coming through like the net zero public sector building standards. But we need a new delivery model to procure Passivhaus and assure the level of build quality expected, and that could potentially come through an offsite delivery model.
Great, thank you. So Sue, coming back to George, he's clarified. Thank you, George, for that. Trying to understand, right, Wraptite's impact on air tightness in a structure, i.e. with an AVCL, the traditional way, and no Wraptite, would the same air tightness levels be achieved?
Again, this is a bit of a it depends question, because just as I was explaining there, using an internal VCL, you generally have more junctions and more penetrations to deal with for your services, etc. Sort of like ducting. So there's probably a higher chance of worse air tightness levels if you're just relying on an internal VCL. Whereas whilst using the Wraptite externally, where it's self-adhered to, to the sheathing board, for example, so there's no air bypass or anything like that. You have, and it's, as we've seen, the use of Wraptite can produce extremely low levels of air tightness. So yeah, it's a bit of it depends situation. Workmanship will obviously have a huge impact on what is achievable in either method.
Yeah, I think to add in a little bit to it as well, I mean, traditionally you can get very good low air tightness values using a traditional AVCL placed internally. But what we're seeing is with something like Wraptite, actually placing externally, you can protect it at an earlier point in the construction, so it's less likely to get damaged, so you can actually maintain that air tightness level. You can potentially test indicative air tightness levels before you cover it in, so that you know if there's a problem. So actually, sometimes concentrating on that external membrane as your air tightness line, getting it safe and secure, and then coming in and looking at the vapor control aspects, which means that actually the install may not be as expensive because you're looking at it from a vapor. You don't have to go down the same minutiae of checking and installation that you would have to if you were actually relying on the internal membrane. Plus, it's less likely that a homeowner is going to stick a nail through to hang a television or a poster or something like that afterwards, and puncturing that air tightness line. So it is very much a case by case basis. So please, George, get in touch with us if there's any specifics on a project that you want to discuss. We're more than happy to do that for you. Peter, I think this could be one for you. I hope I've spelled this right. It's either Ian or Ewan. Sorry, Kavanagh on YouTube. I do apologise. I am rubbish at pronouncing names. can I ask what would be the different challenges in achieving airtightness targets between domestic projects versus larger buildings, be they flats or larger non-domestic buildings? That's a great question.
Again, it depends on the design. You see quite often larger commercial buildings have canopies, rain screen cladding, curtain walling. There's a lot of things where there's a lot of thermal bridging and a lot of detailing for bracketry and support work, which makes it difficult to achieve airtightness. Whereas a domestic setting, you tend to have walls which are quite easy to achieve, which you've got roof trusses which you can work around and detail around. It depends on the fabric of the building, the design of the building, but there are additional architectural features that they like to put onto commercial buildings, which makes it a little bit more difficult.
Yeah, absolutely. Linda, just so that you're not nodding off or anything. An email in here from Jem Blakely. I'm currently looking at a project and really like the ease of install with Wraptite. Do you have something similar I could use, as I'm looking at open jointed cladding and I'm worried about the UV exposure?
We certainly do. We have a product called Wraptite UV. So it's especially for open jointed cladding, if you like. It's very similar to Wraptite, being it's airtight, it's vapor permeable, and it's self-adhered. It's, as you can imagine, it's black in colour, and the installation process is the exact same as the Wraptite membrane. So the main difference is the UV resistant coating that's actually on it. So this makes it more UV stable over time behind the open jointed cladding. So it's a very good product, and it's also useful for programs where we say that, if you like, things are delayed, which Peter will know of on site, might not arrive. So if you've got a longer programming schedule, it can be left uncovered fully for 9 months as well. So it's quite good from that point of view.
Thanks, Linda. Nicola, you might be able to answer this one from Mark Morley on YouTube. He's asking, any idea why Scotland are producing their own version of the Passivhaus standards and not just using the one that's already in place?
Because we've got very specific climatic conditions that are in Scotland, and there's actually a regional climatic difference between even the east and the west coast of Scotland by as much as around 40% in some information that I've read. Yeah, we've just got to do something that's suitable for our building context, really. Yes, Passivhaus is very much a tried and tested system. And we shouldn't fall short of that if we're to ensure that we're going to meet net zero building standards going forward. So we'll just see how it pans out, and hopefully it's not diluted too much. But it's not just operational performance that we need to look at. It needs to include embodied carbon as well, and looking at the materials and things that we're using. So that might be why it's a Scottish equivalent, because we're going to think of more than just what is Passivhaus currently.
Brilliant. Thank you very much, Nicola. Peter, if I can come to you, following on from that, a Twitter question came in from Jarvis Sampson. Can I upgrade my existing house? I'm assuming to Passivhaus standards.
They do. They can do a process which is known as EnerFit, which is part of the Passivhaus standard, where you can retrofit existing buildings using either, there's two separate routes you can go down. They're slightly more lenient with the airtightness values and with the energy values, but there is a process out there that quite a lot more architectural practices are becoming familiar with now.
That's great. Thank you, Peter. So can I come to you with Siddiqui Mohammed's second question on YouTube? Would you say it's preferable to install the airtight layer on the warm side of the insulation or the cold side? Kind of follows on from some of our previous questions.
Yes, I suppose it's very similar to what we were speaking about just earlier. Wraptite obviously is our vapor permeable airtight membrane, and that would preferably be installed on the external side. So that would be on the cold. Well, it depends. Again, it'll depend on the actual build of the construction, but it's preferable to have the airtightness line installed on the outside of the building rather than the outside of the insulation layer, potentially. And that just goes back to the ease of installation in that way, the lack of penetrations. You don't really have to deal with floor and ceiling junctions because they can just be carried on straight over.
I think that's one of the benefits of Wraptite that we're seeing, is placing it actually in the middle of the construction in a lot of cases.
Yeah.
And that can be done because of its vapor neutrality, because it'll allow vapor movement in both ways.
Both ways, yeah.
But by placing it on the sheathing board before you put in your external cladding brackets, rails, and insulation, it does mean that you can have that integrity there without having to try and cut it and fix it around the helping hand brackets, which quite frankly, if you're trying to do that, that's probably a greater nightmare to get that airtight on the cavity side. It's also quite good from a fire point of view, isn't it?
Yeah, and also having the insulation pressed against the membrane as well, you know, like that all helps with, you know, it's not like reducing air movement in that as well.
Yeah, absolutely. Thank you, Sue. Peter, if I can come to you for this one from Mark Morley on YouTube. Are all Passivhaus managers required to be certified tradespersons?
I think being a certified Passivhaus tradesperson, because the training and the hands-on experience gives you more of a familiarity with products and methods to install things. There's a little bit of technical background with it as well that helps you. We're trying to upscale the whole industry here because it's such a new process that everyone's going through. So it definitely is beneficial to be a certified tradesperson.
Great. And if I can stick with you, an email's come in from Robert Moore. He says, what happens if my building doesn't pass certification? It's a question that we actually discussed the other day here in technical.
It depends on how much money you want to spend. You can, you know, you could do investigative works. There is other methods out there. It depends on what it's failed upon, whether it's energy usage. That could be down to appliances that have been installed incorrectly. If it was air tightness, there is products out there that you could retrospectively fit. There's aerosol spray products that you pressurize the building. It could find any of the smaller gaps that you've maybe poorly detailed, you know, during the installation. There is, again, it's a difficult question to answer because there is ways to achieve it, but it depends on how deep down the rabbit hole you want to go. You could end up with a low energy building rather than Passivhaus. If it's your own dwelling, you might be prepared to accept that. If you were doing it for a client, the client might not be prepared to accept that. So it's a difficult question to answer because every situation is different.
Yeah, but it's a really good question actually, because I think people have thought about what happens.
No, we try not to think about that.
Build right in the first place and then it should be fine.
Well, that's part of the Passivhaus process, is get it right first time. So that's what we go for.
Absolutely. Thank you, Peter. And there was one here that's coming from Tony Gordon via email, and I think I'm going to direct it more to the Robertson's team here. Do the team see passive standards as being a solution for the future home standard, or is the estimated 20% cost uplift a barrier for passive to move into the mainstream?
That isn't the cost uplift in our experience. So yeah, 5 to 10%, or Peter, you might have some other figures, but that's our experience to date.
Yeah, I think when you look at commercial buildings, because they're an individual design, you can attribute a slightly higher development cost to them. But if you've got a site for say of 100 houses with 5 house types, you've essentially broken that development cost between 20 houses per type of house. So your development cost is a lot lower. Your material costs can be ordered higher in advance, so you're getting a bigger discount. So there is an uplift in cost. But like I said previously, when you spread that over the lifespan of the building and the actual quality and the lower maintenance and the less snaggings or latent defects, it becomes cost effective rather than cost prohibitive.
And I suppose like that in the larger developments, if you're then replicating that elsewhere and you're learning from the early projects, the costs will start to diminish as you become more familiar with that scenario.
There's already been studies done that the construction costs for a Passivhaus building can be the same as a non-Passivhaus building. It's just the development cost that as more and more people are familiar with the detail and attention, and there's more products becoming available that are Passivhaus certified, the costs will be driven down.
That actually brings on to an email that we've had in, which, Linda, can I pass this one to you? Actually, it's really nicely. Anybody would think we'd make this up. This is from Heather Hendry, and she asks, does Proctor have any Passivhaus certified components?
Very good. Follows on really well, that. Yes, we do. Wraptite is Passivhaus certified. And we also have Project Adapt, which is an AVCL, which is also Passivhaus certified. So you have your outside and your inside covered there with Passivhaus certification. I was just going to ask, Peter, is that one of the reasons that you used the Wraptite membrane was because of Passivhaus certification?
To be fair, no, the reason you don't have to use Passivhaus certified products to achieve Passivhaus certification,
Okay.
but it's because it's a known product, it's self-adhesive, the installation can go a lot quicker, and it's easier to detail on. We had it on the cold side of the insulation, so it is easier to install. So that's why we used it.
Oh, thank you for that.
Thank you. Sue, can I pop this question to you? It was another email came in from Simon Finlay. How can Wraptite reduce the need for EPDM?
Right, okay, so it is important to be aware that Wraptite can't necessarily replace the waterproofing aspect of an EPDM. So you will still need to incorporate these into around your windows and doors, for example, where they are obviously they're your more exposed areas. But where you can cut down on the amount of EPDM used is in situations where you are it's like coming over into bridging areas, for example, from floor junctions, that sort of idea. Still need to consider the use of backing rods, for example, just for your deflection zones, but you can eliminate the need for EPDMs in these areas. One thing to obviously is what's beneficial about that is EPDMs generally tend to be impermeable in nature, whereas obviously the Wraptite is permeable, so that's allowing more areas of that external facade to actually breathe. And it will also help facilitate the drying out of any concrete areas, because they can, the concrete will still be allowed to dry outwards, whilst it's still sort of like damp, wet, for example, and it doesn't push that excess moisture back into the building, which it can do if you had an area that had an impermeable membrane on the outside.
Great, thank you, Sue. Nicola, can I give you this one from the YouTube feed? It's specifically asked of you from Mark Morley. Are suppliers in Scotland set up to provide recycled content or low carbon materials, i.e. GGBS concrete, EAF steelwork, etc.?
Yeah, some suppliers are, but it's in high demand if we're looking to reduce embodied carbon, and the prices are going up for it because people want it. So the supply chain needs to grow. We need to have the right data from the supply chain as well in terms of things like having EPD information. We just need to see how it progresses, but things need to change basically.
Yeah, I think we're seeing some small changes towards it. I know a lot more EPDs are coming online, and
exactly, and that's helpful for doing like embodying and whole life carbon calculations.
Yeah, absolutely. It's something that I know that we've discussed quite a lot in house. Is what do we need to do to facilitate these low carbon designs as they go forward?
Yeah, exactly.
We've got Reese McKenzie here, probably for Nicola or Peter. Do you have any photographs from the Riverside School project which can be shared on the site, shared of the on-site Passivhaus detailing? So any sort of detailing images that can be shared? Or is it strictly a need-to-know basis?
Yeah, no, we keep our secrets. No, I do. I do have a lot of images of the quality of the install and things. So if I get the email address, I'll send some detail and information over.
Brilliant, great. Reese, if you can drop us an email to webinars@proctorgroup.com, we will put you in touch with Peter. Okay, so I think we're getting close to the end of the questions. If there's any else, pass them through now and we'll try and get them done. Sue, can I ask you, George Simpson's question here, are there any situations where you recommend not installing an AVCL?
Okay, not install. I mean, generally, certainly in lightweight structures like steel frame, timber frame, it's always considered good practice to install a vapor control layer. Now, there are obviously various performances of vapor control layer that you can use. So you might not necessarily need a high performing VCL, depending on what your building is, your structure is, internal conditions, for example. But in those types it is considered good practice. You may not want to use a VCL in maybe like a more hard to treat solid wall situation where you want to keep the whole structure permeable and still allow that natural moisture movement from both inside to outside, outside to inside. You may not want to do that in those situations, and in that situation a VCL might not be appropriate. But again, it depends on what you're doing, the type of structure that you're actually doing it in, what you're using that building for example. All these things would all be taken into consideration to decide whether it was necessary or not.
Brilliant, thank you, Sue. Just going through the last couple of questions here. Diki, I know this was a question, but it's really encouraging to hear that you're saying even at the university we're now teaching AT students and architects about Passivhaus, PHP, PNFit and so on. It's really good that they're getting a grounded education in all methodologies available to them. I think that's the way forward, isn't it? Get them young and ingrained. So can I come to this one with you, Mark Drury from YouTube? Does Procter have typical details of their product?
Yes, we do. We have sort of like a lot of details about all our products available. They are available on the website. We can also, if it's a specific detail that he is looking at, then we can view what their detail is. We can overlay, sort of like where our membranes would be positioned, etc. So yes, we'll certainly be able to provide some sort of typical detail for him.
That's great, thanks, Sue. I mean, I think we also say it's very much, we keep joking about it, Ian, our technical director's favourite phrase, that it depends, but quite often there's no such thing as a typical detail, but we're happy to sit and discuss and try and work something out with you as well. Last question here, Linda, if it's okay to ask you, from Moises Coprando on YouTube, cost-wise, what's the cost difference of Wraptite to your normal breather membranes? And I'm asking you because they don't let us techies near prices.
And I'm not sure what answer to give you.
It depends.
It depends. No, when you're looking at something like a Wraptite membrane, it is a lot more expensive than your standard breather membrane or vapor permeable membrane. When it comes to cost, it depends on the project, the quantity that's there. It's like everything else. So I would always say, if you do have a project and it is a large quantity, do come to us and discuss that. Whether you're going through a distribution line or whatever, just come and have a chat with us, because these membranes, like Wraptite, is unique. It does have a self-adhered side to it with adhesive on the back, so it is going to be more expensive than you would do, but then you have to look at the other factors of how easy it would be to install it as well. You're not going to need so many tapes and things like that, so it kind of balances itself out, and it depends on the project that you're actually using it for. So I would just say, come and discuss the cost factor with myself.
Brilliant, thank you, Linda.
Maybe not technical, but with myself.
I don't think we've got any more questions, but I just want to say, Nicola and Peter, is there any final comments you'd like to say before we round up for the day?
There's been some good questions there, so thanks for the session.
Absolutely, some very good questions there. Okay, great. Thank you very much to the entire panel for answering the questions thrown at them. As Nicola said, there were some really cracking questions there. And it's always good to make us think on our feet on a Friday morning with or without coffee to start us off. So we have our next webinar, which is in a month's time on the 30th of June. I can't believe we're halfway through the year already. And
and it's one of our roundtable discussions. So it's a great one to ask more in-depth questions. And we're lucky enough, I'm hoping, to still have Nicola and Peter joining us for that one. We'll be discussing, is entitled Assuring a Low Carbon Future, is the working title at the moment. I'm hoping that I've picked that one up right. So Robertsons are going to be joining us, as well as we hope Anne-Marie Fallon from Archetype, the architects that are involved with a lot of designing of the Passivhaus schools that are going on. So it should be an excellent ability to take this carbon discussion and low carbon design and building to the sort of next level of discussion. So that's on the 10 AM on Friday, the 30th of June. And registrations, if not open now, will be open very, very shortly. So please do get yourself registered for that, not to miss out. So finally, if you've got anything that you need to follow up, please do so. Please drop us an email to webinar@proctorgroup.com. Give us a wee thumbs up on the YouTube channel and send us feedback, which is always useful to be able to learn from that and see what we can do to improve our webinar series. So it just leaves me to say thank you very much to everybody watching, all your questions, and thanks again to the panel, and we will see you next month. Bye, everyone.
Bye.
Goodbye.
Bye, everyone.